Let's dig deeper into it together. I'm not going to make it a data visualization class or Excel charting class, but I'm going to show you from the financial perspective how you are supposed to make the model. As I told you, we need to have interest. We have, let's put it, machine X, EUA, machine Y, and machine Z. Okay, what interest rate we are going to work on? We are going to work on so here you can see better. And we can choose any steps for this. Of course, when you are putting more steps, your curve, your chart would be more accurate. So I'm going for them 10, 15, 20. Okay, now we are going to calculate the equivalent uniform annual worth for this I for each of these cases that we have. Okay, so when I want to calculate that, so it is PMT. What is the rate? The rate is here. I click on that, I freeze it. The number of period for machine X is 6. And the present value that we have is 2000. That is cost. We don't have any FV, and also we have the uniform annual benefit that is already uniform, so I don't need to do anything, and I just put 650. Okay. So it gives me on 0%, and now I drag and get everything over there. I have put the chart here. It's the screenshot of the chart. It is not an Excel chart here. And also, since here we have it until 25%, let's do it until 25%, and here we get it. And when you compare, you see the corresponding, this is 0% when the interest rate is 0%, and here at 0%, X is about 300 something, as you can see here. The next one is 5%. It's somewhere here, and as you can see, it is 256. 10%, very close to 200. 15% here, and 20%. 40 and 25%, it goes beyond, because if you see, if we continue for 25%, of course it goes to the negative part. And so you can notice that between 20% and 25%, it reaches 0. So I'm showing you to see how you are dominant on all the things. You just need to control the things you have learned. Maybe at first when I said you should go and draw it, you said you felt confused how you should start, how you should do that. But exactly, you see, I'm putting you again. Let's go, for example, for this part. It says calculate the PMT, present value of what? Present value of the rate. What is the rate? This 5% that you have. What about the number of years? 6, useful life. And what about the PV? 2000. And this 650 is also the uniform annual benefit that you have. Okay, you get it? And you draw it. You can get the values for thousands of steps and way more numbers of machines and projects that you are evaluating. And the good news, just go and just see. Now we can go and get the same for the other ones, just with some changes that I'm going to show you. For example, for Y. Go ahead, and if you already get it, stop the video and do it yourself. Be greedy regarding learning, regarding practicing. So here for Y, let's update this together. Here we have the interest rate. Interest rate is correct. But what we need to change, it is the NPR, the number of periods. It is not 6 anymore. It is 12, as you can see with machine Y. And other things that we need to change, it is the PV. It is not 2000 anymore. It is 7000. And also we have the uniform annual benefit. It is not 650 anymore. It is 1100. So 7000, 1100, 12. Perfect. Now we have it and we draw it. And again, let's check if it is in alignment with our chart. On 0%, it is 500 something. Machine Y, it is the toppest one, as you can see here. 515 on 0. After that, on 5%, it is 310. 5%, we go for the dashed line. It is absolutely 300 something. For 10%, it is 73. 10%, 73, close to 0. 15%, it is negative. And finally, we are going to do the same thing for Z. For 69, for 0%, as you can see, 5%, it is 300 something. Yes, and 10%, it's about 200. And as you can see, now when you have these, based on this x-axis value that are interest rate, and on this value that you have, you draw such a thing. Although I don't want to make this recording a data visualization session, but I just want to give you an idea that how much it is doable to draw such a thing, although it may seem complicated to some of you, but when I'm showing you this, you should get that idea. If you are curious enough, it is doable. Okay, so we have these numbers that we calculated, and let's see. I select these ones, the values, go for insert, and the chart that I want to use is this one. Okay, so I'm gonna select 4 rows, insert, chart, and here you go, done. Of course, it needs some final touching, for example, about the title, about the legends, but just get the idea that how fast I got it. So when you compare this 600, 600, 400, 200, you see, and it was very fast. So you see this point, this crossing time, that point that you see here is the same as this one. This crossing that you see here, and just notice I just did a couple of clicks for getting that type of thing. Please don't overcomplicate things. Okay, and that's it. We are back in the original page. Still feel free to reach out if you have any question. Make sure you enjoy all the things, the visualization, the analysis, and the depths in financial learning. You get more and more. This is one of my favorite examples in terms of concept. And since now you are getting more familiar and more skilled regarding calculations, so you see now the focus is a little bit tilted toward the concept, toward how to do it, toward the methodology. So here we are going to do an example together with incremental analysis. Now you're familiar with incremental analysis and you have noticed that how much it is helpful. If I want to refer you to some examples that we did before with incremental analysis, and without incremental analysis it would be a little bit difficult to handle it. Just remember the parking permit, because in incremental analysis it is, for example, about the saving. It is in comparison of two cases that you can find in the initial cost and also the benefits. For example, in if you remember, we had two options. One, you pay all in cash 180 parking permit for the year. Another one was you pay 2 6 months payment, one now 130 and the other one 130 6 months later. And when we use incremental analysis, it made the analysis simpler, because very easily you said that it is like that. I'm paying $50 and I'm getting 130 in 6 months. Or another case about that two options for buying the house. So incremental analysis in some cases really helpful, and the best approach to tackle the analysis of the case. So here, of course, we have other ways and simpler ways to handle this case. We have 5 options, 5 alternatives, A, B, C, D, E, with this simple cash flows. They just have initial cost and uniform annual benefit. Which one is the best? It's very easy to just quickly find which one is the best. But here it is just want to give you a practice on incremental analysis when there are more than 2 cases. So please take your time. And I'm not going to bore you by saying that stop the video or stop or any other things. You please handle that, because I'm just going to review the answer together, and the focus in the rest of this video that we are doing together is showing you the methodology of incremental analysis, because maybe still some of you are wondering how we should do the incremental analysis. Okay. The first step in incremental analysis, as we discussed it before, is rearranging the alternatives in order of increasing costs. The same way we did it for parking permit, that we had one case 180 as the initial cost and the other one 130. And we got this 50 difference as the incremental initial investment. So for doing so, anytime you want to do incremental analysis, you need to do that. You need to do that so you can find this extra initial investment. And another point that here we want to check to add to our analysis for the first time is MARR. Of course, we have done it before, but not in details. We just calculated the internal rate of return in one of the cases we did before, and I compare it to MAR. For example, I said over there my MAR is 7%, for example, or 5%. If the internal rate of return is greater than minimum attractive rate of return, I'm going with that. If not, I'm not going to do anything. I will go with that passive investment. I don't need to do anything because I already can get 7% without doing anything. So here we are rearranging or sorting the investment cases that we have from low investment to high. D is the lowest. After that it is B, A, and like that. So here you see it is just the sorted one, correct? So we start with D. I'm just talking about the methodology. So we start with D. We start with D and we have the initial cost of 1,000 and the uniform annual benefit of 117. And the MAR here, MARR, is 10%. It means that, for example, we have an FDIC insured bank that pays 10% annually on our investment without doing anything. And another thing is the useful life. Useful life for all of them is 20, my friends. 20 years. Okay, so we start with D, and with rate, very easily you can calculate the return of the rate of return, but here it goes with that trial and error, but you use it please with Excel, and that's absolutely acceptable, 100%. So it goes and the IRR is calculated as 9.94. Is it acceptable for you? When that FDIC insured bank in your city pays 10%, of course it is not acceptable, because you have specified that your minimum attractive rate of return is 10%. Anything lower than that, cancelled. When without doing anything you can get 10%, why you should do a lot of things to get 9%? So what does it say? Do nothing is preferred. And here it is using a word defender. I like this word in the field of financial management when you are comparing different alternatives. See, MAR of 10%, we are calling it in this case a defender. What does it mean? It means that now it is the best case that we have, and now we are bringing other cases, other economic investment or anything cases to challenge it. So here we have a defender that is MAR of 10%, and we have a challenger that is D, after D is B, and after B is A, and like that. And as soon as a defender is beaten by a challenger, the challenger that beated the last defender becomes the defender. Yeah, it's just fun way of putting it into word. So still D is out of competition and defender is still MAR. Okay, and MAR is doing nothing. Okay, so we continue with B. What we are going to do with B? With B, again, go and calculate the rate of return. And please do all the things yourself. And it's very quick. No need to go, I go and show you. It is just one short line of code to get the rate of return. Make your mind conditional that you can do anything. When I assure you it's possible to be done according to the things you have already learned. Okay, we go for option B, alternative B, 2,410, 20 years. And wow, the internal rate of return is 19%, about 20%. It is greater than. So MAR 10% is out. It is not the defender anymore. Now we have B as our defender with 1996. And after that, we continue to A. You are familiar with this way of analysis because we are going to check. We are paying 2,000 more with A in comparison to B. What more do we get? The more that we get is here. The difference between these two benefits. 229. And as you can see, we pay 2,000 more and we get 229 over 20 years. How much is the internal rate of return for this incremental analysis? 9.63. Is it acceptable? No, it is not acceptable because the internal rate of return for this incremental case that we just did together is smaller than 10%. So, what's your suggestion as an expert in this field? You are going to say, hey, you have 2,000 more, yes? Don't invest it on A. Keep working on B and put this 2,000 into your bank because your bank giving you 10%. But if you invest it in A, it gives you less than 10%. Isn't it beautiful? Isn't it a complete logic? Very rational type of analysis that you can convince any investor in that regard when you are trying to convince them to do this or not to do that. You are saying that it's okay. You have 19% on this. Now about that 2,000 extra. Don't do that because that 2,000 extra you put here brings you less than 10%. And you already have an FDIC insured bank in your city that very easily you can put that $2,000 in that account and get passively without any headache 10%. So what happens? B still remains the challenger. Sorry, B still remains the defender. What about C? Let's go with C. And now with C, you are going to pay $4,000 more. You are going to pay $4,000 more and it gives you back 351. Is it worth it or not? Let's check it together. And again, please do all these calculations on your system, my friends. I'm just focusing here on explaining the scenario, on explaining the case. So here, as you can see, 4,351, and it gives you the return of 6%. The same logic that I said. If you have $4,000 more, don't put it into that project. Just go and put it in the bank. It gives you 10%. And so again, still B. Alternative B is preferred and still is the defender. And let's go for the last challenger, that is E. For the E, 9,000 and oh, terrible results, terrible. It is even less than 1%. Alternative B is still preferred and it is the final selection. It may come to your mind, okay, I will go with this, that 2001, but the amount of payments and everything is here. Don't worry about that. Just get that $7,000 and invest it into that bank account because it gives more. And now you understand better why, when they want to make the economy more active, proactive, they bring the interest rate when they want to fight recessions, or when there is a risk of recessions, they bring the interest rate usually down, because when they bring the interest rate down, people go and invest in B, in A, in C, in E. They invest their money in the economy and they hire people and they start paying, and the economy gonna work better in terms of activity. So they bring it down. So just imagine in this case that we are doing together, MAR was 1%. And we remember just recently, now in this video is recorded in 2025. And I remember it was in 2020. And also at part of 2021, the interest rate was 0 here. And it means that now just imagine the MAR is 1%. Okay, when MAR is 1%, see how much these options would be more attractive. So that's the reason. Now with number, now you can have a better understanding of why, with more quantitative analysis, that what happens when the investors want to decide they should invest or no, they just put their money in the bank. And also the other scenario on the other side, when they want to control the inflation, they want to collect money from the economy, and they increase the MAR, increase the interest rate. So many of the investment alternatives lose it to that high interest rate that is offered. I hope when you are doing all the things on your system, you understand things even better. And of course, whenever you are doing something and you cannot get the numbers don't add up, or you are confused somewhere, feel free to contact me.